Okay, here's our objective. Here's our topic. Uh, and the meaning is when we know Maxwell Boltzmann distribution, we want to be able to use this to justify why not every collision results in a reaction. All right. And here's a review of what the Maxwell Boltzmann's distribution is. All right, it's a probability graph, like a curve, like a bell curve. And we're going to show this with PhET. All right. Now, uh, you can see these molecules are moving around. They're pretty cold, and it's being it's a little laggy, but uh, you can see that there's a recursion urn right there. All right, but nothing is making of the products. All right, and why is that? Well, if you look, not these, not. If I had to show you that none of these particles have sufficient energy, they can't overcome the activation energy. So what do I have to do? I'd have to raise the temperature. All right. I'm going to pause the video. All right. So I've raised the temperature. And now you can see that the total average, they have a lot more than the needed activation energy. And now I have basically allowed some products to be made because I've given the particles enough energy to make um, the product and overcome the activation energy threshold. All right. Now that we've seen that in the PhET, the higher the temperature, the more the reaction can occur. We want to use the Maxwell Boltzmann distribution to show this. So at the start, we had this, and this really should start. You're not going to have sum at 0. It should start there. It should look like this. All right. Now, if you add the activation energy, the minimum amount, you can see that none of the particles have the energy. That's what we were seeing at the beginning. They weren't doing anything. However, when I increase the temperature, some of my particles cross the threshold. And the number of particles is what's represented underneath the graph. All right. So when I warmed it up, some of the particles actually had enough energy to overcome the activation threshold and react. And it's even going to be more so if I increase the temperature to hot, where now I'm going to have lots of particles underneath the curve to the right of the activation energy line. All right. Now here is what I'm saying. All right. Now, with the catalyst, something similar occurs, except the catalyst is going to move this line to the left. It's going to lower it. It's going to diminish it. Therefore, it's going to allow more reactions to occur because all particles are going to now have, more particles in every temperature are going to now have the activation energy needed. All right? All right. Thank you, and I hope this has been helpful.